Okay, so last time, or one of the times, I think last time was externalities. The time before that was looking at the tendencies of government and what we should expect from government. Now, oftentimes there's a reaction to that. Basically, you said, well, right, maybe the only way we get information is not just through lobbying, right? Maybe that, right? So lobbying is where we get the tendency to concentrate benefits and diffuse and spread the costs out. It's why we get short-term tendency or short-term bias. It's why we get bootleggers and Baptists. It's why we have a tendency to move seen to the unseen. But oftentimes the reaction might be, well, but look, that's not the only way our political process works. There is also obviously a chance where we as individuals go to the polls and we express our desires, which is another way of conveying information, and that will serve as an effective check on all of these tendencies. So that would be the question, is does it? What can we expect from the democratic process of voting? So let's think about now some options there. Let's think about whether voting does serve as an effective check. So we have, when you vote, well, there's actually just the question of should you vote? Should you vote? And the sensible thing is going to be to weigh the benefits and the costs. And so if the benefit of voting is greater than or less or equal to the cost of voting, we would expect you to go vote. But again, here's the question. Now that we have externalities in our toolkit here, if I vote, what happens? Well, I bear all of the costs of voting, don't I? I mean, I have to go to the voting booth, I take time off. Maybe in this day and age you can use an absentee ballot in some states. However, if I vote, thus serving as an effective check on all of those tendencies of lobbying, what's going to happen? Do I get all of the benefit? No. In that case, I only get part of the benefit. And so what we would expect is that it will be rational to under-participate in voting, right? Rationally abstain. That's what this, so we can say this would lead us to, not everybody, of course, but a fair number of people. We would expect that well below 100% of the electorate will vote. And in fact, that's actually what happens, right? Even in presidential elections, which tend to get the largest turnout, the last one we saw somewhere around 50% of the population voting. So we end up saying, well, a presidential candidate won more than 50% of the vote, which means that they have more than 25%. So 50% of the population turn out and you win more than 50% of the vote, you are elected with roughly 25% of the population supporting you. Not sure I would call that a mandate. But the key here is that makes perfect sense to us that a large portion of the population actually would abstain. So it's rational for people to abstain. Then the question becomes, for those who do vote, right? So maybe that's not a bad thing. So 50% of the people don't have a clue, and the other 50%, of course, will have an incentive to go ahead and vote because the benefit for them outweighs the cost. And then the question we would ask is, does it make sense for them to be informed about the issues placed in front of them? And again, if they spend the time and energy to inform themselves, to really study the issues and the candidates, what happens? They bear all of the cost. And what happens? Again, a lot of the benefit will redound to or spill over onto the general population. So you could think about, if we made an election, we set an election down to, right, we made one person, their vote was all that counted. They would bear all the costs of being informed, and then the benefit they'd get part of the benefit, but then most of the benefit would spread to the rest of society. And so what this tells us, we think through, is that of those people who go and vote, a majority of them, it will be rational for those people to be ignorant. So we now have that it's rational. If we think seriously about spillovers, it will be rational for most voters or many voters to abstain, and of those who vote, we would expect a lot of them, if not the vast majority, to be ignorant of the issues. And if you think about people and how they talk about voting, I think that's pretty accurate, right? For most people, they say, I'm voting Democrat or I'm voting Republican. Why? Because it's the party of my people. It's my team. In other words, they have very little, if any, idea about the actual issues. So hopefully this starts to be a little bit worrisome about the ability to check the tendencies of government using voting. But you know what? Maybe it's not that gloomy. So we have a small portion of the population voting, and the majority of those who do vote are simply basically flipping a coin, randomly choosing a candidate, and there's a small portion of the population who is going to have an incentive to be well informed about the issues. And maybe then, through all the noise of everybody else flipping coins, we get quality outcomes because of that small portion of the population that votes and the even smaller portion of the population who's informed and vote. Maybe we actually have them deciding the outcome, and so this is sort of the idea of swing voters or, right, independents in elections. And so then the question would be, does it make sense for... Right, so that's pretty optimistic. Fair enough. So here would be the question, why would anybody who was informed vote for bad policies? I mean, we now know that it's going to be in politicians' interest to tell people that bad policies are good. But the question would be, why would the general citizen, knowing, let's take right, so there's obviously the people here, they may just randomly flip a coin, but for these other people, the portion that do vote and are informed, why would they ever vote against their own interests? So let's take a situation right in the last few years. Warren Buffett, a major investor who's made lots and lots of money, I'm sure he's a billionaire more than once over. He came out and even took out ads in the New York Times saying that, you know what, it was unfair that he paid a much lower share of income in taxes than his secretary did. And he felt, look, we should really increase, again, part of that's because of how things get categorized. We should change capital tax rates to actually tax rich people at a higher rate. In effect, let's think about, why would Warren Buffett ever vote for something like this? Do you think he's aware that this would end up increasing his taxes? Sure. And I'm just going to make up some numbers here. Let's say that this tax is going to cost him an additional $10 million. I mean, clearly the benefit of this policy, it's hard to imagine the benefit of voting for this policy, that it would outweigh the 10, I guess I need another decimal or another 3 zeros here. It's really hard to imagine it outweighing $10 million, right? I mean, basically, what would be the issue? Maybe if he votes for it and publicly advocates for it, maybe he might make some new friends. He probably gets invited to some more parties, right? He feels better about himself. He just feels good that he's redressed this wrong in society. Now, it may be that he's so wealthy that $10 million is no big deal. But let's assume that this is actually a significant amount, which I think for pretty much anybody, even somebody who's very, very wealthy, they tend to pay, if anything, more attention to their expenditure. So then how on earth could these things be worth more than $10 million to him? And the key to that is that we don't choose according to our benefit and our cost. What we choose according to is our expected benefit and our expected cost. And for anybody who doesn't remember from way back when, or maybe in your statistics class or in some other class, the expected value of something is the sum of the probabilities of something times the values. So in other words, here we have the value, and the question is, what's the probability? So the probability here, I'm just going to say that the probability is 1. So 100% of the time he's going to make a few new friends, he's going to get invited to some better parties, and he's going to feel good about himself. That seems, or it's so close to 1 that we may as well treat it as 1. Over here, we have $10 million here, and the question is, what is the probability that his vote is decisive? Because that's really the question. If his vote isn't decisive, in other words, if everybody votes for this and he doesn't, he's still going to get this policy. If nobody votes for this and he does, we're still not going to get this policy. And so the question is, what is the likelihood that his vote is decisive? So I'm just going to put this up here. I think that this here, maybe we put some dollar values on this. Maybe the expected value of this stuff might be, oh, for Warren Buffett and the types of parties he gets invited to, right? 1 times 1,000 is 1,000. But clearly $1,000 is not less than, well, is clearly less than 10 million. So now the question is, we need the probability that his vote is decisive times the cost to him if this policy passes. So we have the probability times 10 million. And so now the question becomes, what is the probability that his vote is decisive? His vote is only going to be decisive. In other words, his vote is only going to matter in any meaningful way in cases where there is a tie. So everybody says everybody's vote counts, and it does. But that's not the same thing as saying that everybody's vote matters. In other words, we count everybody's vote, assuming there's no clerical errors. But the only time our vote actually makes a difference is when there's a tie. Now you could argue that, right, a policy winning with 3/4 of the vote says very clearly that this is a policy that people want. Okay, but the difference between winning with 3/4 and 1 vote versus 3/4 minus 1 vote is fundamentally 0. That impact is very, very low because, again, what do we care about? We care about thinking on the margin. So it turns out the probability of a tie here is some fancy math. Oops. And don't freak out. So 1 over pi times n. In this case, we are back in the realm of 3.1417, etc., not profit, times 4p minus 4p squared. Now we have 2 p's here. Yay. P here is the probability. Sorry, that's basically this value here. Maybe I'll put this as f, right? Instead. F is the percentage of the population who is in favor of the policy. Now, don't worry too much about understanding this. I don't fully understand why this is the case, but there's some very bright people out there who have definitively told me that this is indeed the likelihood of a tie. So what this tells us is, as the number of people, oops, I forgot one important piece here, as the number of people who are in this population, in other words, the number of voters. So this is, we're now here in the percentage of the people who are voting. So as the number of people voting goes up, the probability of a tie goes down, holding all else constant, at least with this piece here. So when n goes up, this probability goes down. So in other words, the larger the population, at least on this piece here, the larger the population that is voting, or the larger population that is eligible to vote, if we assume a relatively stable portion of the population voting, the likelihood that your vote matters actually shrinks the larger the number of people voting gets. Now let's look at this piece here. Now this is going to be, right, so this value here is going to be between 0 and 1. Basically, if f is 0, actually this would be -4. My apologies, this is between -4 and, so that's if this was 0, and if this was 1, it would be between 4. So between 4 and -4. And in effect, what happens is, as this goes from 0 to 1, this term increases. But the key is that this, as n goes up, let's see here, as n goes up, this piece holding all else constant, so let's take 1/2, 4. So this would be 2 minus 1 is 1. So that's when this is 1, then as n goes up, there will be no impact on this term. So again, as n goes up, there's still a reduction in the probability here. How about when f is, f equals maybe 1/4. Now we have 1 minus 1 over 16 minus 1/4. And so this is now 3/4. And so as n goes up, this actually gets smaller. So again, tying in with this. So overall, the thing you should take away from both these pieces is that as the number of people in the voting group increases, the likelihood that your vote matters actually shrinks. On the other hand here, the other thing to take away is that the more polarized the populace, so let's take everybody is voting for this value is 4. Everybody is voting against this, so in other words 1, this is -4. Anything in between, right? So basically this value here, and then it's obviously taken to a certain power, so it would get bigger. But basically, the more evenly split these are, the probability of a tie is closer. Sorry. Yes, the likelihood of a tie increases. So in cases where you have a small something is very unpopular and you have a large population, so in other words, as f gets further away from 50%, so right at 1/2, right? This value is going to be pretty good here. Let's see, 4 minus, yeah. But really, probably the more important piece here is that as the population goes up, the probability goes down. So playing with some formulas here. Now, real world, what does this mean? Real world, let me put in some of the parameters for this so that you don't have to do the math. Yep. Oh, that's right. I'm sorry. In that term, yeah, okay. So the more lopsided opinion on a topic is, the less likely there's to be a tie. So let's calculate some examples where n equals 10 and f equals 0.5, then the probability equals, so this is a small group. This is maybe a committee decision or a tenure vote within a department. It's very close, we're not sure. 50% of the population is on each side. We only have 10 people voting. And so the likelihood of a tie is 17.8%. Fairly high, actually. So you have a fairly high likelihood that your vote matters, which is why in department meetings, I usually vote. How about when we get a little bit more broadly? So maybe we have an easy tenure vote, same people, but now we're all pretty much in favor of this person. There's a small group, a smaller group who's not in favor. This here, the likelihood then that your vote matters, 0.0021. In other words, let me move this decimal point so that that is 0.21%. So just changing this here dramatically reduced the likelihood that your vote matters, that it does count, but the likelihood that it matters, the likelihood that your vote affects the outcome now shifts to less than 1% of the time. So it's roughly 1 in 500 chance. Okay, now this is still relatively local. This is still only 10 people. This might be voting where you go to dinner. And this is why oftentimes when we do this, I don't really care, right? Let's just go somewhere. Okay, now let's take a more clear example, maybe let's look at the county level. Maybe now n is 5,000, and we're dealing with a very close election. Then the likelihood that your vote matters here, well, this is still pretty close, but this has gone up a lot. So this probably needs to fall. Let's see. Let's see if it does. The likelihood that your vote matters now is less than, a lot lower. It's been cut about in half. This is about 1 in 1,000. And a moderately close county election, n equals 5,000, f here where we're dealing with 0.53. That's not a very big change here, and yet the probability now becomes 1.18 times 10 to the negative 10th. And what this means is we do 1.18, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Put zeros in for all, so that's the decimal place. And then I'm going to get rid of 2 of those to put it in percentage terms. So that is the likelihood that your vote matters at a county level with an even moderately close outcome here is this number, which is really about 1 in 8 billion. So now you start to think about, if this is this probability here, in effect, the value that you're getting out of this, or sorry, the cost, the expected value of the cost, over here the expected cost, sorry, the expected benefit is 1,000. Over here, once we multiply this probability, this is going to be less than a penny. I think. We could double check.